Hey, what's up, everybody? We're going to be talking more about normal distributions right now, and we're going to talk about something that's just a very important skill to have when you're analyzing normal distributions, and will become more important the further we go in this chapter. And that is the ability to use z-scores when comparing the values of random variables. And in this video, you're going to use z-scores to standardize and compare values of normally distributed random variables. All right. I'll explain what a z-score is as we go. I want to start with this example here where we're going to figure out which of the following two cases is more likely, both involving test scores. Case 1 is that a student scores a 92 or better on a test where the mean is 77 and the standard deviation is 6. And case 2 is that a student scores 24 or better on a test with a mean of 20 and a standard deviation of 2.5. Now please humor me on this. If you watched a previous video, you know how to use your calculator to already calculate each of these probabilities. But what I want to do is I want to show you how to find out what's called the z-score for each of these test scores that we're referring to. Now let me draw a normal curve for each of these scenarios to aid with the explanation. Alright, now what I'm going to do is I'm going to discuss the situation like this. Whenever we're looking at values on a normal curve, we're trying to compare them with the mean value, generally speaking, and we want to know how far is that value away from the mean. Now, whoops, I labeled the wrong mean on each of these actually. Let me fix that. And so whenever I'm asking which of these cases is more likely, I'm wondering, is 92 further away from the mean of 77 than 24 is from a mean of 20? And I don't mean is the absolute difference greater, because certainly 92 is further from 77 than 24 is from 20. But in terms of how many standard deviations away is it, which is greater? That's really the question we're trying to ask. So is 92 more standard deviations away from the mean of 77 when there's a standard deviation of 6 than 24 is from 20 whenever the standard deviation is 2.5. Alright, and the way we'll do that is we'll calculate the z-score. You might recall we talked about the z-scores before, telling you exactly how many standard deviations above or below the mean a value of a random variable is. Alright, well, here's how you calculate a z-score. Very simple. What you have to do is have to figure out what is the absolute difference between a data value and the mean value, and then you've got to divide by what one standard deviation is equal to. So if you have a data value, lowercase x, you want to find out how far away is that from the mean, and then in order to figure out how many standard deviations that is, you have to divide by the standard deviation. This is a little formula that won't be on your formula booklet. You just have to know how to use it. And it's a very common sense kind of thing. Just, again, have to practice it and remember it. So, whenever we're looking at case 1, the z-score would be 92 minus 77 divided by 6. And then 15 divided by 6 is exactly 2.5 actually. All right, so z equals 2.5 right here. That means it's 2.5 standard deviations above the mean, that 92 is. And in case 2, well, we'll have the z is equal to 24 minus 20 divided by the standard deviation 2.5. And so 4 divided by 2.5 is 1.6. Alright, so that's the z-score for the test score of 24 in the second example. Alright, now which data value is more likely? Well, remember, the further away you get from the mean, the less likely it is that a data value will occur. Meaning that if I were to compare the areas, because that's really what we're doing here, if I were to compare the area under this curve that's greater than 92, it would have to be less than the area of the next curve that's greater than 24, because this z-score, or yeah, this z-score is further away from the mean than this one is right there. So case 2 is more likely, just from a pure probability standpoint, which is what you're asking whenever you're talking about whether something's more likely, right? Okay, let me give you a couple more examples of how z-scores can be used. You now see how to calculate a z-score for a data value if you know what the value is and you know the mean and the standard deviation. You also ought to, for instance, be able to find out what the mean is if you know the standard deviation and you know the z-score for a certain value of x. Alright, so here in this example, I'm telling you that the mean value of a random variable x that is normally distributed, you're supposed to find out what that is. Actually, what is the mean value of a random variable x that's normally distributed if you're given that the z-score for when x equals 61 is negative 1.9 and that the standard deviation for the data set is 6.2. Alright, well, if the z-score is negative 1.9, I hope one thing that you notice is that this is a value that is less than the value of the mean. So the mean has to be bigger than 61, you know that for sure. And how are we going to calculate that? Well, we are just going to use the fact that the z-score is equal to the data value minus the mean divided by the standard deviation, right? So here, we know everything but the mean. We can say that the z-score is negative 1.9. The data value for when z is negative 1.9 is 61. And so we'll have that minus the mean that we're trying to find, mu, over the standard deviation, 6.2. And then here all we've got to do is a little bit of algebra. We're going to multiply both sides by the denominator, 6.2. And that'll tell us that negative 11.78 is equal. Yeah, this pen's not working for me. Hold up. Is equal to 61 minus the mean. And then we can subtract 61 and divide by negative 1. And we'll find that the mean value for this data set is 72.28. Alright, now that's a very useful skill to have. One more example here of how you can use z-scores. Alright, another random variable x is normally distributed here. This time I'm telling you the mean, but not the standard deviation. And we're given that z equals 2.1 when x is equal to 240. And what we're going to do with that is we're going to find the probability that this random variable x has a value between 220 and 230. Well, if you're going to take a normally distributed random variable and find the probability of a given range of values, you have to know both the mean and the standard deviation. So we're going to have to use this information right here in order to find out what the standard deviation is, and then we'll be able to find the probability that I'm asking you to find. Alright, so let's go about finding out what the standard deviation is. Let's go ahead and substitute into that z-score equation. We know the z-score here is 2.1, and that's got to be equal to the data value for that z-score, 240, minus the mean, which is 225, divided by the standard deviation. Alright, this is a two-step algebra process. Let's multiply both sides by the denominator. Get 2.1 times standard deviation is equal to 15. May as well go and do that subtraction there. And then, see how many times 2.1 goes into 15. Which tells us that the standard deviation is approximately 7.14 to 3 significant figures. And then, to find the probability that we're looking for, we'll use our normal CDF function as usual on our calculator, and we'll plug in our 220 and our 230 for the boundaries. We'll plug in 225 for the mean, and then we'll plug in the standard deviation that we just found. Now I'd prefer that you use the answer on your calculator rather than actually typing in 7.14. It'll give you a more accurate answer as far as the 3 significant figures is concerned. And we'll find that the probability that this data value is between 220 and 230 is about 0.516, about 51.6% chance. Alright, there's z-scores and a little bit of how you can use them, and they will be very important for the next couple of sections that we're going to cover. All right, as always, I appreciate you watching. Hope you learned something valuable here. See ya.